Welcome to the Critical Few Actions to Improve Your Business podcast. I'm John Downs and I'm here to help you cut through the overwhelm and prioritise what matters most to improve your business. Let's get started and discover the critical few actions that have the biggest impact. I'm privileged to interview Dr. Ellen Pittman. As an academic and consulting specialist in organisation performance analysis and culture change in the health, human services and higher education sectors. Alongside private consulting, Ellen works as a research fellow at the University of Melbourne. She's previously provided strategic policy advice to the Victorian Department of Health during the coronavirus pandemic and led large-scale change programs, including strategy and implementation of a large Commonwealth-funded lean thinking hospital reform program in Tasmania. Today, we're going to talk about how biomimicry can be used to inform or catalyse a new product process innovation initiative. Ellen, welcome. What is biomimicry?
The simplest biomimicry is that combination of bio and mimic. Bio as in derived or inspired from biology or biological systems, and mimic emulating from biology. In essence, it's a discipline that attempts to learn from nature to solve human problems. But it's not really a new concept. Humans have been innovating based on inspirations from nature for eons. Indigenous cultures have been learning from nature to solve problems for thousands of years. And in a Western tradition, we've got Leonardo da Vinci, who created his beautiful designs for flying machines based on the wings of bats. Velcro in the 1950s was derived from having birds stuck to your socks when you're walking through a field. Much more recently, a lot of tech innovation is inspired from nature. For instance, wireless technology uses swarm intelligence theory, and lots of Google use swarm intelligence, which takes inspiration from ants or honeybees around how they transfer information in more networked ways. It's pretty fascinating. We have been doing this, and I can see why you might ask, what's new then? Why are we talking about biomimicry? This is just an ordinary part of innovation. To a degree, that's correct. But what has begun in Western culture is a really haphazard way of learning lessons from nature. Since around the 1990s, grown into a deliberate and methodical way of going about innovation that promises to become the dominant force in tech and scientific innovation, particularly with benefits around environmental sustainability, savings in finding better ways of doing things through biomimicry. There's a lot of financial sustainability benefits involved in biomimicry.
The only problem with common sense is it's not that common. The reality is we've had these teachers of innovation and the catalysts for innovation for literally centuries. But maybe we as a society are getting too clever by trying to ignore it. Some of the answers are already there and it's just a matter of adaptation as opposed to creating from scratch.
Yeah, some of the answers are much better than the answers we tend to come up with. So it's good that we've now got this burgeoning industry, and it's becoming a big part of the way that tech and science innovation is handled these days.
So Jay Harmon, what's his spin on this?
Well, the video he explains it better than I do, but really he's looking at the short clip video, looking at industrial design and the applications of biomimicry.
So Ellen, how can we use biomimicry in the product innovation cycle?
Talk more about the process later, but it's useful to recognise that there's applications in all sorts of industries and business areas. We've just looked at industrial design, applications in agriculture, architecture, construction, energy, food waste innovations, materials, chemistry, sanitation, and these researchers that are now starting to use biomimicry. Pick a couple of these areas to showcase for you.
That'd be good.
Maybe architecture, materials, chemistry might be the most relevant to your viewers.
Sure.
In terms of architecture, a really good example of this is the Eastgate building in Zimbabwe. The client came to the architect and said, I want you to build this huge skyscraper in Zimbabwe, but I want no air conditioning. And I think that's quite a task.
Right.
This brilliant architect had looked to nature for a solution and started to investigate how termite mounds ventilate. So in really hot climates, termites have a need to ventilate, otherwise it might threaten colony. You've seen these termite mounds with great organic structures. They're designed with air ventilation holes throughout the sort of material exterior. And the architect had a look at this and started to design features derived from termite mounds. The building was designed with a lot of thermal mass, which is good in maintaining temperatures. It had a really extended overhang. So it's a very beautiful building. It's got this amazing kind of textured, undulating sort of feel about it, which then covers over windows. So there's very low opportunity for heat absorption through windows, but still letting in light, and uses a really low power fan system at the bottom of the building, which has chimneys all the way through the building that then kind of fans and pumps air from the below all the way through. This building is a great success story. It uses 90% less energy for ventilation than most other buildings, and 35% less energy for overall costs. When I was investigating this building, it saved more than 3.5 million in air conditioning costs. It's an amazing success story.
Yeah.
We conquered a very difficult task. A building in Zimbabwe with no architecture is quite no mean feat.
Zero air conditioning in one of the hottest places on earth is a hell of an achievement.
Yeah.
I'll definitely have to have a good look at that. And you were saying something about materials chemistry.
Yeah, that's right. Another really good example is I think the Mantis shrimp is best known for its amazing light spectrum. It can see 20-something wavelengths of light, whereas humans can see 5 or 6 or 7.
Oh, wow. Yeah.
But that's not for the example I'll give you. The Mantis shrimp have these tiny lips, and they have what's called a dactyl club. They essentially drill through the shell of its prey, through a shell of another shellfish, but they're really tiny little shrimp. They repetitively punch the side of the shell at speeds that are faster than a speeding bullet. There's incredibly fast speeds. The thing that interested scientists about this was that they don't tend to do any damage to their own. Their action is a punching action, not being really sharp. They just have this amazing club that can punch through. I've even heard of people who have accidentally capturing various things and putting them in a fish tank, getting one in a fish tank and turning around and realizing that the Mantis shrimp, they didn't know it was in their fish tank, has shattered the entire fish tank because it can go through the glass. Like, they're really powerful animals. A company called Helicoid Industries realized that the way this dactyl club is created, it's not a solid material in the same way that DNA is a helix in structure. It's these layered helix that goes up, which is helpful for a mantis shrimp to move fast. Beyond the lightweight is also incredibly strong. Helicoid Industries was able to develop lightweight, strong, and impact-resistant composite materials for use in manufacturing, which has been applied now to manufacturing wind turbines, cars, sporting goods, and at the moment I think is really innovating in aeroplanes. Applications that value low material outlay, because these huge big sort of structures, you don't really want to be spending any more money than you need to on materials, but at really high strength and really lightweight. These are some fantastic applications.
That's seriously cool. I'm still thinking about this shrimp. David and Goliath's approach to getting access to it to prey. But yes, you can imagine the benefits to things like wind turbines and airplanes, which when they hit things or when things hit them at extraordinary speeds, it can also have disastrous implications. Wow. I'm going to have to do a bit of research into that.
Yeah.
That's just curious.
Cost and safety. Some of these applications, rare, we can tick all of those boxes at once.
In both of those contexts, it's really about learning from the structures, approaches, communication styles, and composites that have evolved that may give us some insights as to how we might apply it in very different environments. How do you see this as being able to actually inform process improvements of people?
It's just a little bit closer to my background because I'm not a scientist, other than a social scientist. My area of interest as a researcher and management consultant is what we learn from nature around social systems. One of the things I looked at in my PhD is how organisations are structured, led and managed in less hierarchical ways to create a culture with organisational benefits. We want better staff engagement, more accountability within the workforce. So they're not trying to cover up where safety and quality issues have arisen. We want better self-monitoring, more of an appetite for performance improvement and innovation, so continually improve the organisations. We want lower absenteeism and staff turnover. We want lower interprofessional and interdepartmental conflict. Things are associated with less hierarchical ways of working. The less hierarchical, often the happier employees. So I discovered in my research, particularly around looking at what we know from the academic literature, but also from practice, is that we talk about the organisational damage done by hierarchical ways of working, but I'm not sure we know a lot about feasible alternatives. We talk a little bit about network structures and flat organisational structures, but it often feels like, if not hierarchy, then anarchy. How is a leader expected to bring about high performance, reliable outputs, procedures for safety and quality within a context of chaos and change, and without some of these old-fashioned levers of control? I think that's what fascinated me. And I was really interested in where that leads.
Most large organisations have done the divide and conquer, command and control type of environment. And that was pretty popular back in the railroads era 2 centuries ago.
And I've worked in government, outside of government, and universities. They remain very highly hierarchical organisations and suffer from workforce depleting issues. They have more control, but I don't think they have the hearts and minds of their workforce, which is really tricky.
That's a real struggle, isn't it?
My research was done in a hospital setting. I studied a hospital. I took a kind of positive case study. In fact, this is well before I knew anything about biomimicry. I hadn't studied biomimicry at all. I investigated a really in-depth analysis of a hospital that had several decades of performance improvement. Essentially, my PhD tried to understand what's going on here. Why are they able to improve performance, whereas a lot of their peers are stagnating? What I discovered by accident was that hospital functioned a little bit like how a honeybee hive functions. I think it's worthwhile noting that, contrary to popular belief, the queen in a honeybee hive doesn't rule the roost. Wasp hives tend to be much more hierarchical, but honeybee hives operate under direct democracy, where each of the members of a group are afforded decision-making power. We operate under a representative democracy, but they have this consensus-driven way of making decisions. Summer, when a hive has bred a lot, during the summer, the hive can no longer contain all of these bees. They have to break away. Half the hive goes off with the queen, and they make a new queen in the existing hive. The really important survival decision, it doesn't always go well for bees, between a 50% and 75% failure rate for bees, but they have to decide where to rehouse themselves. There's this quite involved decision-making process that's very considered. It's fascinating if you ever want to look into it. I had a look at that after I'd seen some of the behaviour and routines of this great hospital case study, which is working so well. Through that, in my PhD, I created a model for high performance, which cracked the code of how this more harmonious and collective way of working operates.
Yeah.
And I discovered that it relies on a set of collective values, feedback loops for decision making that were alternate to the traditional hierarchies. The feedback loops were ensuring that the right people, the right groups were making the decisions. It's a little more fluid in the sense that in most hierarchies, it tends to be an elite or an executive making the decisions, but the executive doesn't have all the right information. They're not close enough to the problem to understand it. And so there are some efficient feedback loops with constraints to make sure that the leaders were protected from poor decisions. A lot of the decision-making power, particularly around improvement, innovation, was handed back down to the members of the organisation. I've got a few presentations coming up that will go into that. I've presented on it before at a few conferences, so I won't go into incredible depth about that. I'll talk about another model as well, because the hive model isn't the only model that looks at successful social systems. You might have heard of Gore-Tex, the company. We rain jackets and things.
Performance fabrics. Yeah.
That company has some great tech innovation in fabrics, but as well as that, they're actually a really innovative, non-hierarchical company system, which is fascinating. Rather than having employees, they have associates. These associates agree to company-wide and individual commitments that guide their work. Instead of a position description, there's a set of principles that guide their work. And they're not governed top-down either. They do have some leaders, but those leaders are elected by the people that work for them rather than the other way around, which I think is a interesting way to switch around the power. Communications are handled in a more networked way. The last thing about Gore-Tex, which is worth noting, is that when a factory location gets to more than 200 people, like a honeybee hive, they go off and create a new branch, largely because they recognise that they sort of sense that remember the names of 200 people, create a culture there that has that accountability, that has the kind of cohesive way of working. So a sort of village feel of associates who are relatively autonomous, get things done. That seems to be a really important success. Other examples too, like Visa, these big dominant companies that have worked out a way to operate in less hierarchical ways and emulate these ways of working.
Of course, it's the business owner is thinking about this and thinking any mechanism I could apply that would improve decision-making, performance, outcomes, accountability, quality, safety is a win. How does Gore-Tex or any of these organisations, if they have limited leadership, get stuff done?
That's a good question. I think a lot of it comes down to culture. That was certainly the findings in my research. Hospitals are an interesting example because they have a really clear mission. One of the things that is a little scary to hear about hospitals, because I do a lot of research in hospitals, it's not quite surprising to me. But hospitals, we all from the outside think that they're operating in a way that's caring for patients. But what you often find inside a hospital is there's a lot of infighting, there's a lot of professional groups jockeying for a little funding here and there. That's an organisation. They're not particularly well set up to meet the needs and follow their core mission, which needs to be to provide high quality patient care. One of the things I found in this hospital study was how incredibly good this hospital was supporting every worker to put patient care first above competing interests. I think that's how they work. But in answer to your question, it's less a process improvement than it is culture. This is a cultural improvement, and that's where the special sauce lies.
Which is actually doing the staff member, the worker, to make dynamic decisions based on what's the right outcome for the patient.
I think that's one of the interesting things is that often in hospitals and other organisations, workers feel afraid about the persecution and blame if they stuff up. But in hospitals, that can mean life or death. So there's a lot of high stakes issues that might arise. If they feel like they might be blamed or persecuted for doing something wrong, then they're less likely to innovate, they're less likely to own up if they do something wrong or if a mistake has happened. It can be these real cultures of cover-up in terms of innovation and improvement. Plummet. If people can't work cohesively and with some autonomy to say, do you know what, I don't think this is right for a patient, this policy is getting in the way, then people get jaded as well. They find that the structure isn't conducive to helping patients well. I don't want to participate in this anymore. I'm just going to turn up for the paycheck now. And that's not for organisations.
And certainly something that is becoming more often spoken about now, particularly over the last 5 years, is not only the culture of an organisation, but also the sense of psychological safety. Is it safe for me to actually bring up that there are issues? Is it safe for me to actually make decisions? Is it safe for me to collaborate? Is it safe for me to say, actually, you know what, that's not good. That behaviour is not acceptable. That's not the way we do things around here. So that is a critical piece, but that's possibly a conversation for another day. Okay, so how do we then apply biomimicry to product or process development or improvement initiatives?
To think of biomimicry as more than just a technical solution. It has incredible technical benefits. But if you really want to do biomimicry, you've got to think about it as a whole new way of working and thinking about problems. It's a bit of a paradigm shift. Biomimicry needs to be involved well before the product innovation cycle begins and embedded within each stage: design, prototyping, production, and commercialization. It's almost like biomimicry is both the underlying philosophy of design as well as the way that design is applied.
Okay, take me through it.
Prior to product design and innovation, the first important thing to do is to get your head around a couple of biomimicry principles. The very first one is to ask yourself, how would nature do this? Or how would nature solve this? If you're not asking that question, you can't implement biomimicry right at the end. Yeah, that's right. You've missed it. The very first thing is ask, how would nature do this? There are a couple of principles of nature that from that. Nature runs on sunlight. It doesn't run on plugging a tool into the socket and brutally going through something. And because it runs on sunlight, it comes to ways of solving problems. But it only uses the energy it needs to get the job done and no more. Orm has to fit function. It needs to look beautiful, but more than that, it needs to be incredibly functional. Nature recycles everything. It doesn't leave waste. It rewards cooperation more so than competition. It relies on diversity, those sorts of principles. So there is a number of principles of biomimicry that really help. It is a picture of innovation that's much more gentle, requires less energy, less mechanical and chemical force, uses less raw materials, creates less waste. So these are some important principles. And then with these principles in mind, biomimicry employs a process of design which is akin to the prototyping stage in product innovation. Some bits are quite similar to prototyping and other bits vary. The first thing similar to any other design process is to define the problem, look at the problem or the opportunity, the criteria, the constraints, the design brief. The next step is more medic, and that's about trying to translate that problem into using the language of biology. So this is where you're starting to bring the biology thinking to the table and say, okay, how can we reframe the essential functions of whatever it is that we need out of the innovation and the context for the design? How can we reframe that in biological terms and then ask nature for advice about it? And I say ask nature, and I'll talk about it a little bit later, I think, as well, but also asknature.org is a great website that can really help to do this. It has a huge catalogue of fantastic innovations from biological systems that are ripe for use in tech settings and other manufacturing settings. The next step is really discovery. It might be like going to asknature.com or just having a think or getting a biologist involved in what you're doing to look at how that same sort of problem has been solved. Generally, most problems have been solved one way or another through nature. So you look at that sort of discovery phase, and then there's an abstraction phase where you might look at how to reverse engineer natural strategies and then describe them. So it's where we've translated it into biological terms. It's like at this point, we retranslate it back into the terms that make sense to your design brief.
Right.
So we get back out of the bio. Okay, so how does this apply now, and how can we reverse engineer this within the context of the problem you're looking at? And then the next is really like you emulate. So the next phase of the biomimicry design process is where you take that and you try to prototype something and create something that follows those steps. Lastly, you evaluate, and then you might have to go through that cycle again. As we know, you're prototyping and then reprototyping. So the variance is to bring that biological thinking into the way that we design.
You can correlate that to the Eastgate building in Zimbabwe from the point of view of saying, okay, if we're going to, the easiest thing is to build a skyscraper and just bang in a huge amount of HVAC, attach it to the grid and watch all the lights dim in the surrounding areas as it gets on. That's the easy route to glory. To then turn around and say skyscrapers, how are they represented in nature, termite mounds, anthills, I wonder what we can learn from that. Yeah, that was a fairly courageous leap, I would expect. But by the same token, a crucial decision from an infrastructure, power consumption, construction design, innovation. And there must have been some extraordinary engineering requirements to enable such a facility. It really is a courageous venture, but not all of these are on such grand scale.
Absolutely. I think there's a lot of testing, retesting, and a few failures along the way. But I think also because these solutions are derived from natural solutions that have worked, we can see test cases.
Yeah.
It means that process of refinement is there's less risk that it's going to completely fall in a heap and not work at all. It's just about trying to get that recipe exactly right.
So if we're going to apply this, what would be the critical few actions that would help us apply this in business, say, tomorrow?
I think it's quite a shift. The number one shift for me is really around cultivating that mindset. Ask yourself continually, what would nature do? How would nature solve this? Without that, I think it's not going to happen. With that, I think you're halfway there. If you're thinking in those terms, you can start to employ biomimicry and really quite laterally around some of these challenges that confront us. Secondly, try to diversify your professional network around how opportunities might be pursued or challenges in business might be solved for product innovation. I think it's really important that there's good cross-disciplinary collaboration. So you might even want to find a biologist and bring them on to have these natural conversations. In order to translate a termite mound into architecture, it was incredible feats of engineering and design and cross-fertilization between disciplines. So I'd say in thinking about your problems, think more broadly about who you might bring to the table to do the thinking with you. Lee, I think I'd encourage everyone to go have a look at two websites, although they're linked, they're by the same people. There is the Biomimicry Institute, which was begun in America. I maybe in the early 2000s, but their website, because they have such a strong environmental and sustainable mission, they give away so much free, fantastic information. So have a look at the Biomimicry Institute website. And one of their sub-services, which again is completely free, is the asknature.org website, which has this, as I was talking about, this incredible catalogue of already fantastic little case studies of these wonderful, elegant solutions from nature that you can go through and you can filter through and find one that might suit the challenge you're looking at. I think there's some really important resources to get this kicked along. And if you want to talk about biomimetics for high-performing organisational cultures, you can come have a coffee with me.
No, that sounds like a really good idea. Thank you. The resources available, and also I guess it's interesting coming back to what we said at the start, that what's old is new again. And what's really old, like millions of years of evolution, is actually quite new in our product and our service innovation cultures. And certainly from an organisation performance perspective, this has been a hot topic. How do we improve the performance of organisations? It's been a hot topic only for the last couple of centuries. More and more with our, I would have thought, with carbon neutrality, looking at how to be not only more innovative, but more socially and environmentally sympathetic and frankly preservative. This really does offer a lot of solutions, but perhaps not necessarily solutions at first glance, but at least the catalyst to a different way of thinking that may help fundamentally improve product development or innovation process. And our process development, in fact, in a lot of ways, a leadership innovation, because sometimes the best way to lead is actually to not lead, but to coach and empower and allow people to ask the right questions themselves. Ellen, that's been really informative for me. There are so many more questions to ask, and maybe that's a conversation for another day.
It's been a pleasure to have this chat with you, John, and to introduce you to biomimicry. It's something that I feel like I've jumped on the bandwagon and will continue to be astonished as I learn more and more. It's a beautiful field. I think this is the future of problem solving. Very exciting. Thanks, John.
Ellen, thanks so much for your time.
My pleasure. Thank you.
Thanks for listening to the Critical Few Actions podcast. Don't forget to subscribe where you listen to podcasts, follow us on LinkedIn for more insights, and share the show with other business leaders. Stay focused and take action.